Hey, what is up, good people? Welcome to the Incredible Academics YouTube channel, guys. We are going to be looking at the very same problem that we're looking at previously. So basically, we're just going to be plotting this cubic function. Very important. Before we actually dwell into problems that are much more in depth, right? We need to make sure that we've actually mastered our craft, right, when it comes to plotting the cubic function. So that's why for now I'm just focusing on that, and once we're comfortable with this, we're gonna then move right ahead and start focusing on other matters that are sort of like more in depth compared to this. So let's go. Right, so obviously the first thing that we're going to do here, we're just going to try and find the intercepts. So yes, in other words, solve this equation. Solve for x when you've got this equation. Minus 25x minus 12 is equal to 0. So solve for x, okay? And remember what I said. We are first going to find the root through trial and error. Okay, in other words, we are going to be guessing. Okay, so what are we going to try first? Let's check d of 1, and then we'll check d of minus 1, so on and so forth. So d of minus 1 as well, and then d of 2, and then d of minus 2, so on and so forth. So whatever root that's going to give us negative 0, then that's the one. So 2 into 1 cubed. I hope I'm going to be entering this correctly, because I remember the last time there was issues here, and as a result I couldn't find the root. All right, I actually did find the root, but it seemed as if it wasn't the root. Okay, so yeah, so you can see when we substitute 1, we're not getting a 0. So let's try negative 1. Negative. We're not getting a 0, so this is not a root. X equals to negative 1 is not a root, so negative 2, let's see. Negative 2 and negative 2. Not working. And then 2 and again 2. Not working. So let's try 3 and then 3 again, also not working. Minus, yeah, you see this actually requires a lot of patience. Yeah, if you know that patient you're probably not gonna think, that's when I was talking about patience. All right, we finally got it. So d of minus 3 is equal to 0, and this can only happen if x is equal to minus 3 is a root. Right, it's a root. So meaning that now we've got a factor. Okay, so x plus 3 is a factor. Do you get what I'm saying? So we're almost done with the problem. So okay, so now that we've got this, what we're going to do is we're going to say, all right, we know that d of x can then be expressed by what? By x plus 3 multiplied by some quadratic expression. So the question is, okay, To get our 2x cubed, what do we need to multiply the x with? I bet you said 2x squared. Right? And then to get our minus 12, what do we need to multiply our 3 with? Right? What do we need to multiply our 3 with? And I bet you said negative 4. Alright, negative 4. So now let's check. Right? I'm actually noticing something, right? I'm actually noticing something here, that our root is actually a factor of 12. So next time when you're looking for the root, maybe you want to be thinking about you want to be trying out the factors of 12. So factors of 12, that's 6, 2, 12, 1, 3 and 4. I mean, that's still a lot of numbers. Right? But yeah, if I feel like next time I'm just gonna be focusing on the factors of 12. Otherwise, yeah, you're just gonna do a whole lot of work, you know, with the trial and error thing. But let me not confuse you. Do whatever you feel is easier for you. So okay, we've got the first term here and the last term. So the middle term is just gonna be what? Kx. So let's figure out what the kx is gonna be. So k it is given by apples and bananas. All right, and we know that the a is 2, the coefficient of x cubed, yes, and the p is just our root. Remember the root, x is equal to negative 3, so negative 3 there. And then the b, the coefficient of x squared, that's negative 1. Right, the coefficient of x squared, negative 1. Okay, so now this is what? Minus 6 minus 1, negative 7. So great. So d of x becomes what? X plus 3, 2x squared, minus 7x minus 4 is equal to 0. Okay, so to solve for x, we simply set everything that's within the bracket equal to 0. Okay, meaning that x plus 3 is equal to 0, or 2x squared minus 7x minus 4 is equal to 0. So this is in standard form, and the highest power is what? That's 2. Okay, but here the highest power is what? 3. So when that is the situation, you can't use the quadratic formula. But here we can, because this is quadratic. So x is equal to minus 3, or x is equal to minus b plus minus the square root of b squared minus 4ac over 2a. So minus 7 plus minus the square root of minus 7 squared, in brackets please, minus 4, 2, and then the c is what? Minus 4. Okay, and then this is all over what? 2 times the a is a 2. So punch everything into our calculator. Let's see what we're getting. So minus 7 plus the square root of negative 7 squared minus 4 into 2 with negative 4 over 2 times 2. So we've got 4, and let's see what the other root is. Minus 4 or minus 1 over 2. So those are our roots. So our x-intercepts are going to be at minus 3 is to 0, then minus 1 over 2 is to 0 in that order, and then 4 is to 0, exactly in that order. Okay, But just because we've got the x-intercepts, it doesn't mean that the problem is done. Okay, we still need the y-intercept, and obviously the y-intercept, as always, it's just gonna be that number over there, -12. All right, but because we you know, we are insecure and we want to actually, you know, prove it, you know, algebraically that our y-intercept is -12, we're just gonna say, okay, d of 0 is equal to what? D of 0 is equal to, so we're just substituting 0 in place of x. So we're just substituting 0 in place of x. -25, 0 minus 12. So this is how you find your y-intercept. So this is -12, so therefore our y-intercept is going to be at 0 is to -12. Okay, all right, and then we're done with the y-intercepts. I mean the intercepts, x and y-intercept. So now let's focus on what? The turning points. Okay, and then eventually we'll look at the point of inflection. Okay, remember the point of inflection, that's where concavity changes, right? The point whereby the graph moves from being concave up to being concave down, or vice versa, right? Yes. So now how do we find the turning points? Remember, at the turning points, right, at the turning points, m is equal to what? M is equal to 0, right? But remember, our m is the first derivative, so d prime of x is equal to 0. Okay, so meaning that now what is d prime of x? We know that our function is d of x is given by 2x cubed minus x squared minus 25x minus 12. Right, that's our function. So now d prime of x, 3 times the 2, that's 6, and then 3 minus 1, x squared. And if you don't know how to find the first derivative using the rules of differentiation, maybe you must go back to my other videos where I was discussing the power rule, because that's so important. Okay, especially when you have to find the first derivative. So search power rule and you'll find one of my videos. So 6x squared, right, and then minus, so here 2 times the -1, that's -2x. So the 2 minus 1, that's just 1, and you're going to write the 1, and then here it's just going to become minus 25. Right, the -12, that's a constant. The derivative of any constant is 0, so there's no point in writing the 0 there. So this is equal to 0. So now we need to solve for what? So for x, and as you guys know me, I haven't changed as much, so I'm just gonna pull out my quadratic formula and yeah, do what I'm known for: b squared minus 4ac. I don't have time to be thinking about factors and stuff, so as long as we've got the privilege, you know, of using the quadratic formula, I'm going to do that. So most of you guys do this, but when it comes to actually substituting on paper, you guys only substitute here and you end up losing marks. So that's a problem. You write down the formula, but you also substitute on paper. We want to see your substitution on the script. So okay, minus 2, that's the b, plus minus the square root of what? Minus 2 squared minus 4, the a is 6, the c is minus 25. Right, this is all over 2 times the 6. So now that everything is on paper, then we're ready to use the calculator. People rush to the calculator before they put, you know, this on paper. So let's substitute. So minus, the brackets are so important, guys. the brackets are so important, and unless if you you are too comfortable with mathematics and everything, but otherwise please use the brackets. I know sometimes I don't use brackets personally, but that's because I've done this many times. So yeah, but ideally this is what you guys are supposed to be doing to avoid any silly mistakes. So there we go, we have done the substitution. So now it says x is equal to that, so that's 2.21, or minus 1.88. And please, we need you guys to be in the habit of substituting of rounding off to 2 decimal places, right? And don't be surprised, sometimes you are going to get these kind of values by the 10 points, right? Yes, it won't always be integers, do you understand? Which is why it's safe to use your quadratic formula, because I mean, you would have spent like 5 to 6 minutes trying to figure out what the factors are going to be for this equation, only to find that there's actually no factors, right? And then time wasted, you know what I mean? But whereas if you used your quadratic formula, you know, yeah, it's always going to save you time, especially in times of difficulty when there's no factors, right? So okay, so now that we've got the x coordinates of the turning points, now let's go ahead and find the corresponding y values. Remember, to find the corresponding y values, we go back to d of x, not d prime of x. We're not going back to this one. So d of x is given by 2x cubed minus x squared minus 25x minus 12. So we substitute both the x values, right? So d of 2.21, that's going to be 2 into 2.21 cubed minus 2.21 squared minus 25, 2.21 minus 12. And also d of minus 1.88, which is equals to 2 into minus 1 minus 1.88 cubed minus 1.88 squared minus 25 minus 1.88 and minus 12. So those are the corresponding y values, and then let's punch everything in. So 2.21, that's the first one. Right, so 2 times answer cubed minus answer squared minus 25 times answer minus 12. That's minus 50.55, minus 50.55, and then now minus 1.88, right? So 2 answer cubed minus answer squared minus 25 answer minus 12. So that's 18.18. You know, some people are going to say, no, it's not 18,18, it's 18,18. Aha, you all are petty, right? But yeah, so we know that the turning points are going to be 2.21 is to minus 50.55. I'm conforming. And minus 1.88 is to 18.18. It's always gonna, you know, throw me off. Sometimes I'm going to say 88, sometimes I'm going to say 18. So it is what it is, unfortunately. So we've got the turning points now, All right, so what we need now is the point of inflection. Okay, the point of inflection. And remember, with the point of inflection, what you need to do is you need to say, okay, d prime of x, right, is equal to, so I remember we had 6x squared minus 2x, right? I don't know if minus 25 or what. So yes, minus 25, so correct. So we need to then further find the derivative of that in order for us to be able to find the second derivative. Okay, so we're just gonna find the point of inflection. So d double prime of x, in other words, we are now deriving again, right? So that's gonna become 12x minus 2 is equal to what? 0. So now whatever x value that we're going to get, that's going to be the x coordinate of the concavity point. All right, so 12x is equal to 2 and x is equal to 1 over 6. So now we go back to d of x, which is 2x squared cubed, sorry, minus x squared minus 25x minus 12. So we substitute the x value, so d of 1 over 6. We try to find the x coordinate of the concavity point, 1 over 6 minus 1 over 6 squared minus 25, 1 over 6 minus the 12. Okay, so now let's check. So 6, that's our answer. So 2 answer cubed minus answer squared minus 25 answer minus 12. So we're getting minus 16.19. So minus 16.19. So we've got the concavity point. So 1 over 6 is to minus 16.19. So the problem is done. So now we just need to look at the coefficient of x cubed and figure out what the shape is going to be. Okay, what the shape is going to be. So by the look of things, the coefficient of x cubed is actually positive. So we're going to have a shape like this. Okay, that's the kind of shape that we're going to have. Right, so there we go. There we go. So right, so that's our graph right there. So we just need to plot in the values. So turning points, x-intercepts. Right, so the first one is going to be minus 3 is to 0. This one is going to be minus half is to 0. The last one is going to be 4 is to 0. And then the turning points, if you guys still remember, 2.21 is to minus 50.55. So 2.21 is to minus 50.55. And then the other one, it's minus 1.88. Minus 1.88 is to what? Is to 18.18. So 18.18. And the y-intercept, I remember it's 0 is to minus 12. Right? And then we just found the concavity point. So it's probably somewhere here. Alright, and it's going to be minus 1.8. No. The concavity point. Okay, concavity point. It's somewhere here. all right, because you can see the x value is positive. So 1 over 6 is to minus 16.19. So the graph is done basically. So this is your function d. All right. So we've got the x and y intercepts, we've got the turning points, we've got the point of inflection. So ladies and gentlemen, we've come to the end of this part, and I hope you guys learned a lot, and all the best.